concepts. So the basic syntax is we'll have a initialization, then there is a condition, there is an update. So initialization will be executed only once, then condition will be executed every iteration, then it's going to perform the update. If, if the condition is true, the code, whatever you have written in the block, it is going to be executed. And we have seen the few examples, we have seen that. A few examples we have seen. Yeah. And these are some of the examples we have written. So if we take this here, one of the example. Yeah, day 3, if you take this here. So factorial of a given number. When you take the factorial of a given number, how are you going to find the factorial of a given number? We are taking the initial value, we are initializing with the 1, and we are running the loop from 2 to until that given number, and we are multiplying, and finally we will be printing the, once this loop is over by the time, so it will be multiplied 1 into 2 into 3 into up to that number, and we are storing that result in a fact, and finally we will be displaying that result as a, this is the result we are displaying. So this is what we learned in the last class. Today we will discuss about the while loop and switch statement. We'll discuss. With that, we have covered all the fundamental concepts. So when you're taking the while loop is also same as a for loop, but as a while loop will have the only condition. While we are going to write the expression, if this expression is evaluated to be true, then this code is going to get executed. But here we are doing the initialization and updation. Initialization we'll do before loop starts. Updation we'll do inside the loop. Inside the loop, you will be doing that here. So here, when you take the while loop syntax is this. While there is an expression, and we are going to open and close that here. And whatever you are going to write it here, the initialization you will be writing before starting up the loop. The updation you would be writing inside the loop, you are going to write it here. Now, let's take it as a simple example. We'll discuss with the example. I'm going to create the package name I'm creating here, day 4. And here we are writing a example, new, I'm going to create a class. So this example we are writing it as a multiplication of the table only, we are going to take it here. Multiplication of table. We will be taking the multiplication of the table, same example I'm taking here. We are going to write with the while loop. This is the main method I'm writing here. And when you take the while loop, so here first we are taking it as a number equal to 19. If we want to print the 19th table, we want to print it here. So what I will be taking here, int I equal to 1. Initially, I'm initializing here, and I'm writing the while loop. While I less than or equal to 10. Until I less than or equal to 10. Until I less than or equal to 10. And I'm saying that you print this value, and you increment the I value by 1. If we don't do this incrementation, what happens is here, this will be running in the infinite loop. If you don't do the incrementation, this is going to run it in infinite loop. The reason is 1 is less than or equal to 10. It is always true. 1 is less than or equal to 10. It is always a true. It's going to run it in the infinite loop. So number 19 into 1 equal to 19. It will be printed infinite times. It is going to print. We need to make this condition false. So we are updating the I value by 1. I plus plus. I'm going to do this here. So the moment you run this example, it's going to print the 19th table. 19 ones are 19 up to 19 tens are, it is going to print it here. So how this is executing, we'll see with by keeping the debugger here. I'm going to keep the debugger here. I'm putting the debugger here. How this is executing, yes, we are going to debug in now multiplication of the table. We are going to debug. The debuggers will help you to you will be running this program so whether you want to go to the next step, or you want to go to the step into And we can see that this all the values, how the variables are created here. If you look at this here, the number is 19. Okay, then I value is a 1 initially. Then it is checking the condition. I'm saying that step over. That means it will go to the next step. And this condition is true, it is executed. Then it is going to execute this. The I value is incremented. Now, initially it was 1. And after this step, the I value will become the 2. I value is become the 2. Now it is checking here. Is it 2 is less than or equal to 10? Yes, condition is true. Again, it will execute this and I value incremented. Now 3. Again, condition is true. It is printing. Now 4. So up to it will go to the 10. Then the moment it becomes the 11, here now it is going to be 11. Is it 11 is less than 10? No, condition is false. Then it's going to come out of that. It's going to come out of the while loop. Now you can run this here, and by the time you will be getting the output as this is what you are getting. Whenever you get a doubt how this is working, put a breakpoint wherever you want to stop your controller and you see that how that is executing. Put the breakpoint there, and you can use the step over or step into. You can use it here. Step over means you go to the next step. Step into means if you are calling the method, if you want to go inside that method, we will be using the step into. You are going to use it here. This is a way you can debug your applications. You can debug here. Now here we are taking the while loop. When you're writing the while, it will have the expression. The initialization will be done outside and updation will be done inside the loop. We are going to do that. Let's take it as here. Then why do you want to use the while loop? It's the for loop is a simple loop. Why do you need to use the while loops? So typically when you use the while loops, the for loops you will use it here. You are sure how many iterations it has to run. There are times we are not sure how many iterations it has to run that, but we know the condition. We know the condition, but we don't know how many iterations it will take. In such a scenarios, we would use while loop than the for loop. Okay, let's take it as another example. I'm going to take it here. Here we are taking a number. I'm going to take a number 1, 2, 3, 4, 5. Okay, or 1, 2, 3, 4. We'll take it as another number 9, 8, 9, 8, 1. Okay, 9, 8, 1, 9 I'm taking here. I need to find the sum of all the digits. I want to find it here. 9, 8, 1, 9. I need to find the sum of digits. When you are finding the sum of digits, how do you do that here? I need to get the 9 out, then I need to get the 1 out, and I need to get the 8 out, and I need to get the 9 out. If I add all these variables, if I add all these things, you would get the, here 8. Okay, 1 is the 8. How do we need to get it here? Then we are going to get the 9. Total, it is going to be 27. This is what they are asking us to do that here. We need to find the sum of digits. We need to find the sum of digits of this given number. We need to find it here. Now, when you take the number system, when you take a number system, we have a decimal numbers and we have a octal, binary, and hexadecimal. Okay, hexadecimals we are having here. These are the number systems. Okay, hexadecimals we are going to take it here. Hexadecimals we are going to take it here. Hexadecimals you would be taking here. Binary, when you take that here, the binary, if I'm taking a number, it's a 1, 0, 1, 0, 1. Like, this is having the base 2. This we call it as a binary number. The binary numbers will have the minimum is 0, maximum is 1. When you take the binary numbers, so that will have the base 2. Base 2 is the number system when you are representing here. The binary numbers will have the base 2. So how do you convert? Suppose if I give the decimal number is a 25. We want to convert this value to the binary number we want to convert here. In order to convert that here, so you would be doing like this. 2 12s are the remainder is 1. 2, 6 are remainder is 0. 2 3s are 2 3s are remainder is 0. 2 1s are remainder is a 1. If you write it in a reverse order, this would be 1 1 0 0 1. So this is what the binary equivalent of the 25. The binary number equivalent of the 25 is this the number. How do you convert binary to the decimal? 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube, 2 to the power of 4. Okay. So 2 to the power of 1, that's a 1 into 2 to the power of 4 plus 1 into 2 cube. So 0 into anything 0 0. 1 into 2 to the power of 0 means that's a 1. 2 into 2, 2 into 2, 2. This is a 16 plus this is a 8 plus 1, which is nothing but the 25. This is what in the school mathematics we learned here. Whenever you take the number, suppose if I'm taking the 9 1 9 8 1 9, if I take that here, this is a 10 to the power of 0, 10 to the power of 1, 1, 10 square. Then here we are going to take the 10 cube, we are going to take it here. So if you do that here, 9 into 10 cube plus 8 into 10 square, then you are going to take the plus 1 into 10 to the power of 4, 1 plus 9 into 10 to the power of 0. If you calculate that, this is a result, you would be getting that here. Okay. So this is a way the numbers when you're taking here, when you're taking the base 2, that's a binary number. Base 10 is a decimal number. Base 8 is octal. Base 16 is the hexadecimal value. Hexadecimal values. This is what typically the number system will be used in the number system is used. Okay. Now here, when I'm taking here, my number 9819. So this I want to find the sum of all the digits. I want to find it here. I need to find the sum of all digits. What we could do here is first I'm going to get the 9819. From this number, I want to take the 9 out and I want to make it as a number as a 981. Next time I'll take the 1 out and I'll make it as a 98. Then next I'll take the 8 out, then I'll make it as a 9. Next time 9 out and I'll make it as a 0. Then if I add all these variables, if I add all these values, now I'm done with the sum of 4 digits. Then here the question will arise as here, how do I do this here? We know that it's a decimal number. What we can take it here, let's take it as a one number. I'm going to take it here. Okay, this is a table. I'm going to write it here. And here we are going to take it as a some value. I'm going to take it here. And I'm going to take the remainder. I'm going to take it here. These are the variables I'm taking here. The number value is a 9819. Initially, some value I'll take it as a 0. Initially, I'll take it as a some value as a 0. Now I will divide. I will get the remainder. I'll get the remainder. I will get it here. In the first step, I'm going to get the remainder as a 9. And I'll add this remainder to the sum. Okay, I'll add the remainder to the sum. I'm going to add it here. This is a 9. It is going to be. And I'll update this number with the 981. Again, I will get the 1 out. Okay. And I'll add to the sum, which is going to become the 10. And I'll update this to the 98. I'll get the again 8 as a remainder. I'll get it here. And I'll add to this here 18. Then I will update this value to the 9. Again, I'm going to do this here. This is a 9. I'll get it here. 18 plus 9, 27. And this value I'll update it with the 0. If I do this here, the moment it became the 0, I got my result. I got the result. I got it here. So this is what logic we are going to take it here, and we want to write this logic. How are you going to write this logic? First, we are going to take it as a number equal to, this is a number equal to 9819. I'm going to take it here. And here we are taking the sum equal to, initially I will be put it as a 0. And here we are writing a while loop. While my number is not equal to 0, number is not equal to 0, then you want to do this here. What is that? First, I want to get the remainder. How I'm going to get the remainder? Remainder equal to number modulus of 10. If I do this, I'll get the number modulus of 10. I'll get the remainder. This remainder value I'm going to add to the sum. I'm adding to the sum. Sum plus equal to R. And now I have to update this value. Otherwise, it never be equal to 0. Like no, this value will not be equal to 0. I'm updating this number value. Number equal to number divided by 10. So this is what I'm number divided by 10. If I do this here, this value will be dividing with the 10, and that will be assigned here. Why are you doing with the 10? Why not some other number? Because it's a decimal number. We are doing with the, to get the remainder, I'm doing the modulus of 10 and I'm dividing with the 10. I'm going to do that here. So once you do this here, the moment it becomes the 0, and what is the sum value you got it here, you're going to print it as the output. What are the sum value you got it here? Just you are going to print the S out. S out, we are going to print it as S out, system.out.println, the sum value you would be printing here. Okay, sum value you would be printing here. Now here we need to understand here, we don't know how many iterations it takes, but we know the condition. We know the condition. Like this is the cases where we would use the while loop than the for loops. Yeah, so we will take it as an example. We'll write that here. Now I'm going to write a example for that. New Java class, I'm going to take it here. Sum of digits of given number. Okay. So we will take a number from the user, SYS out. We are going to say that as a, okay, or we will take it as a just a simple number. We will take it here. Int number equal to, I will be taking it as a number equal to 9819. We'll take the same number. The first thing is we need to know, we are going to find the sum of digits. So here I'm taking the one variable int sum equal to 0, and we are writing a condition while my number is not equal to 0. Until my number becomes the 0, you keep on do this. We are going to say that here. Now here we are going to get the int r equal to remainder equal to this, and we are doing the sum equal to sum plus r, and then we are doing here number equal to number divided by 10. You can write it here plus r. There is no point in repeating the same variable name, and you can write the division. You're going to write it as a num divided by 10. This is what we are doing here. And after that, we are going to print the sum of digits is just you are going to print the sum. We are going to print it here. Now here there is a one catch. Suppose I want to retain this value as is, like I don't want to disturb this value. So then what you could do here is we can take the int temp equal to, I'm taking the temporary variable num, we are going to take it here, and we are doing the temp value, you are going to do that here. Okay, I'm going to make modification temp value. Okay, temp value, because we are making it as a 0, I will be losing this value. I don't want to lose this value. Just we are going to say that here, SYS out, the sum of, this is what we would be saying here. Hey, so the sum of digits of this number is this. So we are assigning this value to the one temporary variable, because here in our logic, we are making it as a 0. I'll be losing this value. I don't want to lose this value. I want to retain that. For that, we are assigning this variable to the one temporary variable I'm assigning. That temporary variable you are using, and we are making it as 0. And so that when I'm printing the output, I know what is my input number, what is that output number. Now, if I run this here, I would be getting this number output as a 27 I should get. Oh, it became the 0. Why it became 0? Why it became 0? Because we added the here, the temporary variable we added here. It's not temporary variable. We would be adding to the sum. We would be adding to the sum. We are going to do this here. Now let's put it as a breakpoint. We are going to debug this application, how it is working. Now I'm going to run. Okay, I'm going to run this here. Yeah. So now here initially the number values are 9819 temporary also. The sum value is initialized 0. Is it not equal to 0? This is a true. Then I'm getting here, this is a value. If I do the remainder value, it got it as a 9. Some value was 0 and we are adding the 9. That's it is going to become the 9. And temp equal to temp divided by 10. Temp equal to temp divided by 10. If I do this here, this value will become the condition is true. The value become the 981. Okay. 981 it became. Again, it is going to run this here. The temp value here equal to 981 divided by 10, which is 1. So then remainder plus already some value was 9 plus 1 you're adding here, it is going to be a 10. Then you are doing the here dividing this here 98. Again, it does that here 98. If you do that 8, so 10 plus 8, 18. Again, you do that 9 plus, okay, 18 plus 9, 27. And this value is divided. It becomes the 0. 0 is not equal to 0. Condition is false. Then it is going to come out of this while loop. And where we are going to print the output. Okay, this is what output it's printing here. This sum of digits is 27. You are going to get it here. So this is a way you can use the while loops. You can use it here. Now, one small important point, just I want to highlight here. Here, the variables you declared inside the while loop, the scope of that variables is only within this block. Once this block execution is over, these variables are going to destroy. The scope of this variable is within this method. Like you can access anywhere in this method, you can access here. But this variable you cannot access outside because the scope of this variable is only within this block. That's the reason if I take it inside, then what happens every time the sum value will be initialized with the initial value. We don't want to do that here. Until this loop is runs, the sum value it has to be retained. We declare the sum value as outside we declared, and we are using inside the loop we are using here. So what are the variables you declared inside the curly braces? It will become, the scope will become the local to that scope. So this is a way we would be using the while loops, and this is the basic syntax of the while loop. Any questions? Good. Yeah. Now we'll discuss one more example, then we'll go ahead with the discussing the other topics we'll discuss here. Now, what I want to do here is I want to find the reverse of a given number and check the whether given number is a palindrome or not. Reverse of a given number and check the given number is a palindrome or not. Now here we are going to create a class, a reverse of given number. A reverse of a given number, we are going to do this here. Okay, reverse of a given number, and we need to check that here. Okay, reverse of a given number we would be doing here, and we need to check that here whether given number is palindrome or not. We need to check that here. Reverse of a given number, and we need to check the given number is a palindrome or not. How do you find the reverse of a given number? Okay, let's take it as the same example I'm going to discuss here. Okay, this is a 9, 8, 9, 8, and 8, 9. I'm going to take it here. Okay, 9, 8. First, we'll take the not a palindrome number. 7, 9. We are going to take it here. When I take this number, and if you are doing the reverse of this number, the expected output is 9, 8, 7, 9. This is what we are expecting. 9, 8, 7, 9. We are expecting here. Okay. Hey guys, you guys are with me? Do you have anyone has any questions? Can someone respond, please? Yeah.
No, sir. Good to go.
It's absolutely like no whether my you guys are with me. I'm not. Just I got it out. Yeah, fine. Here we are taking here, this is a number we are taking here, 9789. And this, we need to do the reverse of this number. And the expected output is, this is what. Once you know the sum of digits, the reverse of a given number, palindrome, and sum of the digits until it gets the single digit number, this all falls in the same category. Now, what you are doing here is, we are doing the sum is just we are adding. Here we need to do the multiplication. We need to do that here. So first, let me explain the logic here. Then we'll write the code for that. I'm going to take it here. The number value is this is a number value I'm taking here. Then I'm taking the R value I'm taking here. Reminder, or REV value I'm taking here. And then I'm taking the reminder. Okay, I'm taking the reminder. I'm going to take it here. Now, if you take this here, okay, this is what we are going to write it here. So the number value initially, it is a 97 and 89. We are going to take it here. Okay, I should have taken the. Okay, we'll write it here. The number value I'm going to take it as this is the number value. This is the RE value. And this is the R value. I'm going to take it here. Okay, the number value is initially it is a 9789. 9789. We are going to take it here. The RE value initially I will take it as a 0. Then we need to calculate the remainder. How we are going to do this here? First, you get the remainder. Okay, first you get the remainder, and you do this REV into REV equal to, we are going to do the one extra thing we are doing here. REV into 10 plus R. Why are you multiplying with the 10? Because this number, when you are getting the first place, it is a 10 to the power of 0. Next is a 10 to the power of 1. We need to multiply every time with the 10. Then we'll get that number. Now what I'm doing here, REV equal to REV into 10. Okay, first you get the remainder, 9. REV equal to REV initially 0, 0 into 10, 0 plus R. The remainder is a 9, which is going to be 9. Then we are updating this number to the 978. We are dividing with the 10. Again, you get the remainder. This is a 8. This is a value is 8. REV 9. 9 into 10, 90 plus R, 98. Again, you update this number, 97. 7 is out. Reminder, 980 into 10, 980, 987. Okay, now here update this value, 9. Okay, this reminder is 9. 987, 9 we are going to get it here. And this value, if you divide that here, it will become the 0. By the time I got it, the value as my reverse of this number, I got it here. 9879, we got it here. So we will be writing the same code. We are going to write it here. This is the main method. I'm going to write it here. Okay, we are going to take the main method we are writing here. What I'm doing here into number equal to 9879. We are going to take it here. Now we are assigning to the temporary variable, and then we are going to do the int REV equal to 0. While I'm going to take it as a temp is not equal to 0, the R equal to temp modulus of 10, REV equal to REV into 10 plus R. Then we are getting the temp equal to temp divided by 10. And finally, we are going to print the SYS out. Reverse of the given number is, this is what we are going to print it here. When I do the reverse, what is the value you are getting here? Just you would be printing that reverse value. We are going to print it here. So when you do this reverse, this is the value you are going to get it here. This is the value you would be getting that here. Now we need to check that here, whether given number is a palindrome or not. Okay, palindrome means what? Whenever you read any word from right to left, left to right, if it is having the same set of characters, that we call it as a palindrome. Now, whether given number is a palindrome or not, how do you check that? If you take the original number, and if you do the reverse of that number, and if you compare the original number with the reverse number, if both are same, then we can say it as a palindrome. It is a palindrome. Now here we are going to check that here. What I'm taking here, if my number is equal to REV, the number is a palindrome. Otherwise, you are going to say it as it is not a palindrome. Now here we are going to write it here. Run. We would be running this example, and it's going to tell that here whether given number is a palindrome or not. It's checking here. It's not a palindrome. It is saying here. Suppose if I'm giving the 9, 8, a 9, if I give that here, the reverse also it would be the same. Okay. I just want to go on mute, please. Yeah. Okay. 9, 8. This is a palindrome. It is saying here. Okay. The reverse of. Yeah, there's somebody microphone is on. You please go on mute. Yeah. So this is a reverse of 9, 8, 8, 9. This is value we are taking here 9, 8, 8, 9. It's if you do the reverse, you are getting the same thing. And when you are checking here after reverse, we are checking that if number value is equal to REV, we are saying it as a palindrome. Otherwise, it is not palindrome. We are saying here. This is the way we can check whether a given number is a palindrome or not. We are going to check that here. Here, this is the best place to introduce the new concept. Hey, I don't want to mix my reverse of logic and the sum of digits. I want to write it as a separate methods. I want to write it here. I want to reuse in multiple places. Here, I cannot reuse this code. Suppose if you want to use this sum and the reverse of numbers, reverse of a given number, I want to reuse it in another class. I cannot do that because everything we have written inside the main method you have written. We cannot you cannot call this logic, or you cannot reuse this logic. In order to reuse the logic, you can write a methods. Okay, how do you write the methods? When you're taking the methods in any programming language, either Java or any other programming language, it would be the same. Whenever you're writing the method signature is typically like this. This is you're going to write it as a method will have the return type. Okay, and here you will give the method name, and then we'll have the argument. Like no args you will have it here. Number of arguments you will have it here, and then it will have the method. What is the method logic you are going to write it here? You would be writing here. Typically, when you write the methods will have the. This is the 4 types of methods you will have it here. Method with return type, with argument. Okay, the first one is method with return type and with argument. What does it mean? The method will take the something and it is going to return the something. The method is going to take the something and it is going to return you the something. This is the meaning of that here. We call it as a fruitful functions. You are investing something and you are giving something and you are expecting something. Such a methods we call it as a fruitful methods. So now here, how do you define this method? Example, I'm telling you that here. I want to get the reverse. I'm doing the reverse of, I'll be taking here int number. This method is saying that here, hey, you give me the integer value. When you are calling me, you give me the integer value. I will return you the another integer value. You give me the number, I will reverse it, and I am going to return you the reverse number. I'll return you the reverse of that number. It is going to return here. Now, next type is method with return type without argument. Without argument. What does it mean? The method is going to return the something for you, but you need not to pass the any argument. So let's take it as a local date. Get system date. Okay, I'm asking hey, give me the system date. I'm asking here. We are not passing any argument. When I'm calling this method, we need not to pass any argument. I'm asking the get system date. It is going to give the what is the system date. It is going to return that here. Here we'll write a logic which is going to return the system date. It is going to return. It has the return type, but it doesn't have the any argument. Now the next one is method without return type with argument. Okay, without return type with argument. Now what you are doing here is you are writing a one method void. If there is no return type means explicitly we must write the okay explicitly we should write the void. Void means it is not returning any value. That's the meaning of that here. Void is it is not returning any value. So here we are going to say it as a show greetings. Let's take it here show greetings. I'm writing here string message. String message I'm going to say that here. Now here when I write this method we are giving the argument. We are giving the argument, but we are not returning anything here. This method is going to not returning anything here. So this is a argument. You are giving the arguments, but it's not going to return anything. Then the fourth one is without return type, without arguments. Without argument, you are going to say that here. This is a void show system config. Okay, so this is going to display the system configuration. It is going to display that here. We are not returning, we are not expecting any return value. We are not expecting here. So these are the four types of methods you will write it here. It is like you are giving the input, you are expecting the something written, and this method is saying that here, if you give me the input, I will return you this. Even if you don't give me the input, if you call me this method, I'm going to give you the what is the system date. And here it is saying that whatever you give it here, I'm going to print it, but I'm not going to return anything. This method is saying that you just call me that without any arguments. I will tell you the information, but I'm not going to return you anything here. In a lighter note, you can take it here like no. Whenever you invest on somebody or if you give something to somebody, you are expecting something return. No, this is a typical scenarios like no, if you are investing or if you are giving something to in some other form, you are expecting something. No, this is a method example. If you take that here, we are sometimes we are lucky. So especially you will get it from the last place. You are not going to give anything here, even though still you are getting here. No. And here we are going to take, you are going to give it here. Like no, this is like no, your donations, you can say that here. You are always giving, but you are not expecting anything here. You have no expectations, nothing like no, you are not going to give anything. You are not also expecting anything. This is a way you can remember the methods when you are writing here. So methods you will write it in four ways. One is with return type, with arguments, without return type, and with arguments, no return type, and with arguments, without arguments, and the return type we are expecting here. So this is a whenever you're writing in any programming language, it is a be it in Java or Python or like some other language, C or C++. If you take that here, this is a typical the method declarations you will be using here. Now here we are going to define a few methods we'll define here. Now I'm going to write it as a new class. This is a math common questions. Math common questions, you are going to take it here. Okay, what we are doing here is typically commonly people ask what are the questions they will ask. We would be taking here one method I'm writing here. Here I'm writing a public static. I'm writing the public static int GCD. Okay, GCD of two numbers into number 1 comma into number 2. This is a one method we are going to take it here. In GCD of two numbers, you are going to take it here. Int GCD of two numbers. And this is you are expecting the return value. That's the integer type it should return. And now here we are writing here into static int biggest of, we are going to take the number 1, number 2, number 3. Now here we are going to find the public static. I'm going to take it here int reverse. Okay, then here we are going to check that here sum of digits, and here we are going to write the boolean is prime. Then you are writing the is palindrome. So these are the some of the examples we are writing it as the methods you are writing here. Hey, I want to find the GCD of two numbers. I want to find the biggest of three numbers, reverse of a given number, sum of digits, and is palindrome, and the is prime, and we are going to check the is palindrome. Now you think like no, this method is like a it's like a person. It is saying that here, hey, if you give me the two numbers, I'm going to return you the GCD of these two numbers. I'm going to return. Now you may ask the one more question. Hey, how do I know what input I'm getting? You don't care about that. You know that this is an integer. This is also integer. You need to think that here, the person who is calling is going to pass the two integer values. What value? You don't care about that. Now you need to write a logic in such a way that here, hey, if you can imagine like no, is sending the 9 and 12 is sending here. How I'm going to write the GCD of these two numbers? How do I find the GCD of two numbers? Here we are doing the basic check. If number one is number one and number equal to number two, if both the numbers are same, then you can return the one of the number you can return. So GCD of is passing the all the possible combinations. We need to check that here. If number one and number two, if he is giving here, both are same. If he gives that here, we are going to return the number one or number two. It doesn't matter. No, both are same numbers. Now we are checking the one more condition. Okay, here we are going to check this here. If we are going to set as a number one equal to 0 or number two equal to 0. So if he is sending the number one is 0 or number two is 0, then we are going to give it as a returning him as a 0. Okay, the 0 is we are going to say that here. Okay, this is another case. The third case we are going to take it here while number one is not equal to number two. Until this number one is not equal to number two. If it is not equal to number one is not equal to number two, you are doing here number one is greater than number two. Number one equal to number one minus number two, else number two equal to number two minus number one. The moment this both become the equal, we are going to return either number one or number two. You are going to return because both the values are same. You will be returning the number one or number two. Now, how do you test this? Whether it is working or not, how do you know that? You have written a method. You did not write any main method or anything, and you can write a main method and you can test that here. Okay, you can write a main method and we are going to test it here. What we can do here is quickly to test that here. We will write a main method and I'll show you that how do you write the test cases for this today. Yeah. Now here we are going to write a main method I'm writing here. Quickly, I want to test that here into number one equal to, I'm going to take it as a 16 into number two equal to, I'm going to take it as a 24 I'm taking here. Now we need to know what is the GCD of these two numbers. GCD of two numbers, you are going to take it here. If you take the 16 and we are taking the 24, so we need to find the greatest common divisor. We need to find it here. Now the logic what we have written here, is it 0? Both are same? No. None of these cases are executed here. Is it not equal to? Yes. Number one is greater than number two? No. Then what we are doing here is 16, 24 minus 16, which is 8. Now again, is it same? No. 16 minus 8, 8 and 8, both are same. The GCD is it is going to be 8. That's the result it is. The logic what we have written here, is it both the numbers are same? No. Is it one of this number is 0? No. Then it is not equal to. If number one is greater than number two, I'm subtracting number one, number two, I'm subtracting from the number one. Otherwise, number two, I'm subtracting with the number one, I'm subtracting. And this process we are doing until both the numbers are equal. The moment it becomes equal, then we are going to return the number one, we are going to return. Either number one or number two, both are same. You will be returning here. Now, how do I test this here? Here we are going to get the int result equal to, I'm going to call this method, I'm going to print it here. GCD of number one and number two is what is the value you would be printing here. Now I'm going to run this here. I'll be checking this here. What is the result? I would be printing that. Missing return type. All these things is giving the compilation errors. For time being, I can return. So to avoid the compilation error, I'm going to return 0. I'm going to return here. Okay, return 0. And here also we are going to do the return 0, just to avoid the compilation error. Return 0. Here we are going to return the false. And here we are going to return the false. We are going to return here. Okay. To avoid the compilation error, just I have taken the default value I'm returning. Now I'm going to run this here. This would print the GCD of 16 and 24 is 8. It is going to print it here. This is the way you would be writing the method, and you can call that method wherever you want. You can call it here. Wherever you want, you can call it here. When you are asking this, somebody is asking the, can you write the algorithm? That means they are asking you to write the method. They are not worried about the how we are taking the input scanner class or some other means you are taking. They are not asking. That's not important for them. They are asking the, can you write a algorithm? That means, so you need to write a one method, and what is the implementation that exactly it is going to behave. You would be implementing that. You would be writing that code. You are going to write it here. Cool. Now here we need to find the biggest of three numbers. It's a simple thing. We are going to find the biggest of three numbers. If number one is, you would be writing like this. Number one is greater than number two, you return this. Otherwise, if it is a case, you return the number two. Otherwise, number one, number three. We are done with that method. Now we need to do the reverse of a given number. Just now we discussed that here. How are you going to do this here? So int rev equal to, initially we'll take it as a 0. Then we are going to do this here, and finally we are going to return the rev value. Rev value would be written here. The sum of digits, again we discussed that here. Int sum equal to 0, we are going to take it here. Then we are going to write it here, and finally we are going to return the sum value you are writing here. Now whether given number is, we need to find the prime number. We need to find the whether given number is a prime number or not. We need to check that here. The prime number, we know that the number which is divisible by 1 and itself, we call it as a prime number. The number which is divisible by 1 and itself, that we call it as a prime number. In other way, you can take it here. Any number divisible by other than 1 and itself, we can say it is not a prime number. So you can check that here. If number modulus of 2 equal to 0, and here we are going to say it as a number is not equal to 0, not equal to 2, we are going to return it as a false. There is no even prime numbers, only 2 is the even prime number. We are checking that here. If number is modulus of 2 equal to 0, and number is not equal to 0, and the number is not equal to 0, then we are going to return it as a false. Okay, this is a one condition. This is a one condition. Here we are going to add a one more condition. We are adding here, number is less than 2. Number is less than 2. If there is any negative number or less than 2, if you get that here, it is not a prime number. We are going to return here. Or if number is equal to 0, and number modulus of number is, when you divide this even number, and if it is not equal to 2, then we are going to say it as it is a false. It is not a prime number. Then we are checking that here. One more we are checking here. For I'm going to take the 2 from the 2 to half of that number, or square root of that number, or half of that number. Okay, we can take it as a number divided by 2. Till half of that number, I'm going to take it here, and I'm dividing that each time. I'm dividing 2 to half of that number, because if we take the any number, factors is always 1 to half of that number. Maximum is half of that number, and after that we don't have that number. We are excluding the 1 and itself, anyhow it is going to divide, and from 2 to half of that number we are taking, and we are checking that any number divides this number. If that is the case, immediately we are going to say it as it is not a prime number. If this statement never executed, then it is going to come out of the for loop, and we are going to return it as a true. Here the logic is this is what. If it is a less than 2, if it is not a even number, okay, if it is an even number, then we are going to say it as it is not a prime. Then you are dividing with the 2 to half of that number. If any number divides that, it's not a prime number. We are going to return it as a false. So this condition never executed. That means it is a prime number. all possibilities you are taking here, which are not like no, to check the it is not prime number. It's not prime. You check the all the possible combinations. None of these cases are executed. Then that means it is a prime number. This is the way you are writing a logic to check the whether given number is a prime number or not. Now here we need to check the palindrome. When you're checking the palindrome, you know how to do the reverse. Reverse of already we have a method. Hey, reverse of this number. The result of this is equal to this number. We return it as a true. Otherwise, it is going to return it as a false. The palindrome logic, we are going to make use of the reverse method. We are going to make use of that here. What is that reverse method? This is going to return me the reverse value. I'm checking that here. Hey, if the reverse of this number, like no, what is the result it gets here? If it is equal to this number, we are saying it as it's a palindrome. We need not to repeat this logic once again because already we have a method. We are going to make use of that. Suppose tomorrow somebody is asked you to check that here. One more method you are writing here, public. Okay, just we are going to take the list of integer. I'll discuss what is this list of integer in upcoming sessions. For time being, you can take it here. They are asking to generate the prime numbers between this range. Okay, they are asking to generate the prime numbers between this range, and they are asking to give it as in a container object list. They are asking. Now, when you are doing this here, it's a simple thing. Here we are going to create a list of integer. I'm going to take it here. This is a prime list. I'm going to create one new array list. I'm going to create it here. Okay, one container object I'm creating. To put all my prime numbers, I'm creating the container object. What I'm doing here is I'm running a for loop for int I equal to LB, lower bound. Okay, int I less than or equal to UB I plus plus. If this is a prime number, is prime. Already we have a method. We are calling the is prime. If it is a prime number, you add to this list you are saying. And finally, once the loop is over, we are going to return the prime list you are going to return here. We are running this loop. I equal to LB to UB and I plus plus. We are making use of the existing method, is prime method. If this is a true, we are adding to the prime list dot add. We are adding the I value. And finally, we are going to return the prime list you are going to return. This is a way you can do. You can make use of the existing methods. You can make use of that. You will not write the code, the same code again and again. Just we'll make a one separate class. We'll make it here. Util class. We'll make it, and we would be using that here. That's what exactly we have done that. No, if you take the math, I want to find the. Let's take it here. This is an example. One more example you're writing here. Private, public, static, double. We are going to say that here. And I'm going to find the power. Okay, sum of series. Okay. Okay, sum of series, we are going to take it here, or we are going to say it as a power. Int m to the power of n. We need to find the m to the power of n. We need to find it here. Like no, typically we'll write this logic, but we need not to write this logic. Just you can do here is return math dot power. We can do that here. This is a method they have written. The library method, the way they are going to give it here, static math, they are going to use the compute, and internally this is a logic they have written. They have written the logic to find the power of that number. Okay, so now here in our case, okay, in our case we are not going to worry about how the logic they have written, and like if you want to learn, we can go and check that here. But already it is available. There is no point in wasting the time. Just you are going to make use of that method and you would be written here. So this is the main advantage of the methods. The methods can be reused. Once you write the method, that method can be reused. Any number of times you can call it here. Okay, all the places I'm taking the public static. Why I'm taking the public static is, okay, this is giving the warning. Like now, whenever you get the warning, you just look at that here. Why this giving the warning, and they're saying that here. You call the max call. Okay. Now they are saying that here, hey, since I don't know, this is a logic you are having here. You return the number one, and there is there is a method called to find the max of two numbers. You can call the math.max. You call this here. One of the number it's going to return, either number one or number two. So just we would be whenever you got there such a warnings, just have a look that here, why they are saying that warning, so that they will give the suggestions also. Then we can see that here that suggestions, will it work for us or not. If it is a valid suggestion, then you can take that suggestion. Like this is a simple one. Like instead of writing one more ternary operator, we can use the math.max number one and number two and number three. I'm going to give it here, and which is going to return me the one of the maximum value. It is going to return here. Yeah, cool. You can do the method chaining also. Like no, uh, we could have done like this. Okay, this example could have been made it as a much simpler. Like no, here we are going to do this here. Max of math dot max. I'm going to take it as a number one, comma. This is a what? This will work. We are saying that, hey, you find when you are taking the method calls like this, first it is going to find the maximum value. It is going to find the maximum value. And once you get the maximum value, we are going to find what is the maximum value of this and the result of this. Then you got the biggest of three numbers. You're calling this method. And what are the result it is going to return here? This value we are comparing with this value. And finally, you would be finding the max of three numbers you are finding here. Yeah, this is a way you can make use of the existing methods. You can make use of that. Okay, cool. Now, whether things are working or not, all these methods are working or not, you have written a code, there is no problem, and you are confident that everything is working. What is the evidence like no? So how do you know that these all methods are working? Not today, tomorrow, if you see that here there is some performance issue, or you want to change this logic to instead of doing this here, I want to do the recursion, I want to do that here. Whenever somebody makes the changes and they have to test that, the testing, you will be writing the main method, you are going to write it here. This is not a viable option. Like no, if your application, when you're working in application, it will be huge code base. You cannot keep on writing the main method in every class and you cannot test that. That's a cases where we could write the unit tests. You can write it here. As a developer, I have written the several methods I have written, and I need to ensure that these things are working. These things are working, and like no, you have to write the test cases for that here. All possible cases you are going to write it here, and you will be testing your code. You are going to test that here, and whenever in future, if say make some modification, if you run the test cases, if everything is working fine, that means as a developer, we are ensured that the things are not broken and things are working fine. Okay, how do you write the test cases? I will be discussing now. Is this clear? Any questions? Does anyone has any questions? Any questions, guys? At least someone respond, please.
No, sir.
No, sir. No, sir.
How are you going to write the test cases? You will be seeing that here. Now here we have a test package. Now I want to write the test cases. I want to write it here. In order to write the test cases, there is something called the JUnit 5. Okay, this is JUnit 5. We are going to use the framework. So this JUnit 5, if you take it here, whenever you are writing the unit test cases, the most popularly used unit testing framework is a JUnit. And JUnit is the latest version, is the JUnit 5 we are having, they have released, and we would be using the JUnit 5. We are going to use it here. And if you go to the user guide and how to do that, and this is the explanation, you will get it here. Writing the unit test by using the Jupyter, how do you write that here? This is what, like now, whenever you are writing the unit test cases, you are going to write it as a test, and then you are doing this some assumption whether whatever the value it is returning, and this is what you are expecting. And when you call this method, is it returning the same or not? We are going to check that here. If it is returning, that means there is no problem. It is absolutely fine, and you can say that no, this test case is going to pass, and we don't have any issues. In order to use this framework, we need to add the dependencies. We need to add that library into your form.xml file. We need to add that into your form.xml file. We need to add it here. And this is a one library which is required for us. Okay, just we are going to take this is the dependency. We need to add it here. And this dependency you would be adding inside the form.xml file. You are going to take the form.xml file, and where we are going to add the third-party dependencies, I'm adding here. And here we are going to say it as a dependency. And here we are going to say it as a JUnit Jupyter engine. I'm going to select it here. And what is the latest version? It is going to pick that here. And the scope is a test. This is a library. When the test cases are running, this library is available. And we need not to download the physically that libraries. If we add it in, since anyhow we have taken the Maven project, the moment you add the dependency, what are the transitive dependencies it is having here? It is going to download all the libraries. Okay, just you refresh here. You can see here external libraries. This is what I added the Jupyter. Jupyter has got the if you look at here, Jupyter has got we added the Jupyter engine we added here, and it has pulled the several other libraries. It is pulled here because those libraries has having the transitive dependency on this library. Whenever you use the Maven, this is the one of the advantage. Whenever you are using the Maven, the main advantage is if you add the dependent, if you add the library, if that library is having the dependency on the some other library may be having the dependency on the some other library, all the things it is going to pull and it will be added to your class path. It will reduce the lot of developer efforts. Like whenever you change the version, which are the compatible libraries, those compatible libraries it is going to be pulled. And when you are pushing the code to the source code repository, we will not push any of these libraries, just you will push the form.xml file. The moment you import this project, and in your case, what are the dependencies are required, automatically it will be pulled from the Maven central repository. It is going to pull that dependencies, it is going to pull that here. This is the way you would be adding the third-party dependencies into your project. You are going to add it here. Now we added that here. Now what we are doing here is you are going to create a new class. This is a class. First we'll create a package. New package, I'm going to create it here. This is a com dot. Okay, CareerIT dot. I'm saying it as a JFS. Okay, what is the package name you have given? Okay, learning for Java. Okay. And we'll take it as a day 4. Okay, I created the same package. I created day 4, and I'm going to write the new class I'm creating here. Math common questions. Okay, questions test. I'm going to take it here. This is a test class I'm taking here. Math common question test I'm taking here. Now, first thing is I want to find the biggest of 3 numbers. I want to find it here. I want to write the test case for the biggest of 3 numbers. So now here we are writing here void biggest of 3 numbers. 3 numbers big as big at first. Okay, that's good. Cool. We are writing a test case. We are writing here. Okay, so the biggest of 3 numbers, biggest as a first. Okay, now here we are going to take it as the test case we are writing here. What is that? We are going to take it here. We are taking the 3 variables we are taking here. Int a equal to 100, b equal to 200, 3 equal to this. And big is a 300. Here we are going to take it here. This is 100, and this is a 200. My big value is the first value. Now I want to do this here. I want to call this method. What is that? Int. Here we are going to get it as the actual value equal to. You are going to take it as a math.common question, the biggest of. Okay, you are going to take the number 1, number 2, number 3, or ABC. Yeah, here we are going to take it as a ABC. Now here, what we are expecting? Okay, assert equals. We are going to take it as a assert equals. I am expecting the. Okay, this is the assertions dot. Okay, assertions dot assert equals. Assertions dot assert equals This is what I'm expecting. What is the expected value here? Here we are going to say it as an int expected. 300 I'm expecting, and I'm going to compare with the expected value with the actual value. I'm going to compare. If this is a true, then there is our logic is working fine. There is no issue. I have taken the three numbers and I'm making it as my first number as a maximum value, and I'm going to call this method. This is the actual result it is going to give it here. What I am expecting here when I'm calling this method, I'm expecting the 300 as a result. And I'm checking that here. Assert equals my expected value, the actual value, both are same or not. We are going to compare. And you would be adding the at the rate of test. We are going to add it here. At the rate of test, we are going to add it here. The same thing we are going to run it here. The second case, we are going to run this here. The same biggest of three numbers, all the corner cases we will be writing, and we are going to test this here. This is the second case. This is the third case. This is the fourth case. 4 cases I'm writing here. Now this is a place. It's a biggest at second. Okay, biggest at second. We are going to take it here, and this is the biggest at third. Okay, then all are same with the same values. Biggest of three numbers with the same numbers. Okay, now here we are going to make it as a 300. You are making it as a 300. You know what you are expecting here. When I pass the biggest of three numbers, if I pass all the equal values, I'm expecting 300. Now my biggest value is 300. Here we are going to take it as a 300. This is a 200. This is a 100. My biggest value at the third place, whether it is getting that or not, we are checking here. Now biggest value at the second place. This is a 200, 300. This is a 100. If this all the test cases are passed, at least we are ensuring that, okay, if all the three numbers are same, is it working or not? If third value is the biggest value, is it working or not? Second value is the biggest value, is it working or not? First value, it is biggest, it is working or not? We are checking that here. And you can check the negative numbers also. We can check the negative numbers at, we are going to say that here, void biggest with, okay, negative numbers. Okay, I'm expecting the -100 is a big. Is it working or not? We are going to check that here. One method you are writing here, we have written the 4 test cases you have written. Always you remember, whenever you are writing the code, the source code, if you write the 10 lines, and the test cases, sometimes it may be 100 lines also. Compared to source code, you'll have the more test code, you'll have it. The testing you will do not like now whether it's working today or like we are not doing the testing for whether it is working today. So like in the future, if somebody changes the logic, whether it is working or not, we need to check that. And whenever you change the logic, you in order to test that here, every time you cannot go and write the main method. He has got the already test cases. If all the test cases are passed, that means what are the logic he is going to change it here. He is changed here. If it is if test cases are not breaking, then that means things are looking fine. This is what we got the proper result. Now I decided to change the logic. I'm going to this class. Hey, I don't want to use this here. I'm going to write the if else conditions I'm writing here. Okay, if this is a case, we are going to write it here. Else we are going to write it here. And here we are going to write it here. Else I would be writing the number 3, and we are going to close this here. Okay, this is the logic I have written here. Okay, this is the logic I have written here. I made some logic changes. I made it here. I made some logic changes. I made it here. Whether things are working or not, how do you test that here? You go back to the test cases. You run this test case. If it pass all the things, that means your logic is fine. There is no issue. There is no issue. Yeah, test cases are working. There is no problem. There is no problem. So math common questions here, we are going to change it here logic, and if here we would be doing here this is a case, or here we are going to return math.max of. Okay, here we are going to take the number 2 and number 3. Yeah, this is also absolutely fine. If this is the case, it is going to return. Otherwise, you are going to compare with the number one and number two. You are going to compare. How do I test? Just go back and run the test cases. If it comes all the things, then we don't have any problem, which is working fine. This is the way you would be writing the test cases. You would be writing here. Sometimes before writing the method itself, you will write the test cases. Let me give a simple example. I'm going to write a method. Here I'm going to write it here. Int public public static int factorial. Okay. Or we can say it as a sum of digits until single digit sum. I haven't written the any logic here. I'm going to return the 0. 0 I'm going to return here. I want to write the test case for this. Okay, now I'm going to write the test case. I'm going to write it here. You'll go to this class, and here we are going to write the one method we are writing here. Void sum of digits until single digits. Okay, until single digits using single digit number. Single digit number, we are going to say that here. Okay, cool. What does it mean? I'm taking the int number equal to 9. Okay, this is what, and what I'm expecting here, my expecting value is also 9. Whether it is working or not, just I want to check that here. Sum of digits until single digit number. If I give the 9, there until single digit number means what? Okay, let me explain that first. Here we are going to take the 9819. If I add all these things, you are going to get the 27. If I add the, you will get the 27. If I add the 2 plus 7, which is 9, this is, we call it as a single digit sum. 9819. If I take that here, if I add this value, you are getting the 27. And again, if I add that here, it is going to result is going to be a 9. So this is what single digit sum we want to get it here. Now here, if I pass my single digit number, I'm going to do this here at the rate of test. I'm going to write it here. This test case is going to fail. Why it is failing? Just we'll see that here. I'm running this test case. It is failed. Expected was 9 and its actual value is a 0 because we haven't implemented that method. Now we are going to write one more test case. We are going to write it here. Now I will be writing here one more test case. I'm going to write it here. Okay, with multiple digits. Okay, multiple digits. You are going to take it here. Here we are going to take the 9819. So what is the expected value I'm getting here? 9. So is it coming properly or not? Just you want to check that here. This test case also will fail because our method is not yet implemented. Now you know that clearly your input, if I give this input, this is the expected value. If I give this is the expected value. You need to write a logic for that. Now here we are going and writing your logic. You are going to write it here. How do I find the sum of digits? So here you will be checking that here. If number is greater than 1, less than 10, okay, less than 10, you are going to return the number itself. Otherwise, you are going to do this here. Otherwise, you are going to write a one while loop. You are going to write it here. Okay, here we can do the one more way we can do that here. There are multiple ways you can solve this problem, and simplest one I'm going to tell you that here. 9819. If you take this value, 9819, you can take the 981 plus 9, which is going to be a 990. Now, next one is 99 plus 0, which is a value is nothing but the 99. 9 plus 9, which is nothing but the 18. 1 plus 8, which is nothing but the 9. There is no 2 digits. Now we are done with that. So to do this logic, we are going to write it here. While number is greater than 9, I'm going to do this here. Okay, I'm going to do this here. Okay, here we are going to do this here. Cool. Number equal to number divided by 10. Number modulus of 10, we are going to do this here. Finally, we are going to return the number. If my number is greater than 9, you are going to do this here, number modulus of 9. And here we are doing the number modulus of 10, number modulus of 10 and number divided by 10. We are going to do that here. Finally, you are going to return the number value I'm returning here. Now I'm going to run my test cases I'm running here. So in this case, is it true? Obviously, it is going to be true. Okay, I'm running this test case. Yeah, it's passed. I'm running this test case. Is it getting the right output or not? Just you are going to check that here. Yeah, it is working fine. So this is one way you are doing here. Other way is could be already we have a reverse of the sum of digits. We have a method. What you could do here is yeah, instead of this logic, I want to make use of this. While number is greater than 9, we are going to do this here. Finally, we are going to return the result. That's it. We are going to already we have a sum of digits. If it is a greater than 9, we would be returning this is a value you are going to return here. If it is not greater than 9, directly it will come here and it's going to return this value. It's going to return this value. It's going to return here. Is it working or not? How do you check that here? You can run all the test cases now. Okay, we have a bunch of test cases. We are going to run all these things. If this is works, that means we don't have any issues. The code is working fine. In the projects, this is the way you will write logic and you will be testing by using the JUnit. You are going to use it here. Now, these things are working. Why should I use this here? Just I'm going to give this here. This is another logic you will be writing here. So you will be writing the test cases. You will not write the main method in every class. You will not write the main method. So what are the utility you have written? You would be writing the test cases and you would be testing whether things is working or not. If it's everything is working, then you will push that code to the your GitHub repositories you would be pushing. Now, then the people who are doing the manual testing, they will do the manual testing, and the people who are doing the QA, they will do the QA testing. And if there is a test automated suits are available, they will be running that. That's the screen level, they will be doing the testing. But as a developer, so what are the methods you have written? What are the functionalities you have done? You need to write the JUnits for that. This is the way you would be writing the unit testing. You are going to write it. Is this clear? So each method you guys can try writing the test cases for that. You know that what is this method? What are the possible options? So you can give that here. Like no, you can give the even number. You can give the negative number. Is it like no, all the corner cases? Like no, what are the cases you want to test that here? You call that method and you test that. If something is missing, you can come back here and you can fix that code. That's a way you can write the test cases. You can write it here. Any questions here? Any test cases? Sorry, any questions? Not test cases. Cool. Nobody wants to respond. Okay.
Sir,
Yeah.
we use JUnit to see if the code we wrote is correct or not, right, sir?
Correct. The code.
Okay, so we will write the program in JUnit to test, or we'll write the program somewhere and or we'll test here.
No. You have somewhere. We are testing that. Okay, this is also. Yeah.
Can you repeat it, sir? I can't hear it.
Okay. Your system is mute. Here, what I'm saying.
No, sir. There are some breaks. Maybe I'll mute it, then I can hear properly. I don't know. I'll mute it and you can answer, sir.
If we go on mute, then I'll explain that. Okay, here the JUnit is also a Java code. As a developer, whatever you have developed the components, you need to test that here. For testing, you would be using the JUnit. Now you have written one module you have written. This module has got you have written a component, and this has got the lot of methods you have written here. You need to test that here. When you are testing that, you are going to use all the possible combinations. You are going to write it under whether is it returning the expected result or not. We are going to test that. Once everything is fine, then you would be releasing for the code you are going to release. Without testing that, you shouldn't be doing that here. This testing can be done in multiple ways. One is you can write the JUnit test cases, or manually you write the main method and you can test that here. Or in the manual testing also, people will go to the screen and they will enter the inputs and they will be testing that here. But as a developer, it's good to write the JUnit test cases. Whatever your code you have written, whether things are working or not, you will get to know that. If you are taking the biggest of three numbers, some simple example you have taken, all the cases you have checked. First number as a big, second number as a big, third number as a big. If I give all the numbers are equal, if I give the negative numbers, if all the cases, what are the possible cases it's required? I tested all these things. If this works, that means that code is working fine. Then in future, if somebody makes the changes in the code, they want to test that. They need not to reinvent the wheel to write the same test case. Just you can make use of that, and you are going to run these test cases. What are the changes you made? If it is not breaking any test cases, that code is working fine. This is a way you will be ensuring that the existing code, if you make any modification, it's not breaking the code. The first step is you will test through the JUnit test cases.
Thank you, sir.
Yeah. This is the responsibility of the developer, not the tester. The developer has to write the JUnit test cases. The testers will not write the JUnit test cases. Yeah, you need to write that. Cool. Okay, it's time. Yeah, it's 23. Yeah, we'll stop it today. Here, I supposed to discuss this switch statement, and we have only 6 minutes. We'll discuss in the next class. And tomorrow we don't have the session. We'll be meeting on Monday. Yeah. Thank you, guys. See you.
Thank you, sir.
Thank you, sir.
Stop sharing.
Sir,